Can you see my slide deck that says Tech Academy Intro to JavaScript class? Awesome. Thanks, Abubakar. It's Abubakar. Excellent. Thank you. All right. So welcome. This is me. I'm Erik Gross, senior level software developer. I've been programming computers since I was around 11 years old. I'm a U.S. Navy veteran. I was a nuclear reactor operator and electronics technician in the Navy. And that's also where I discovered that I really like to teach. And I'm the co-founder of the Tech Academy, which is the organization that puts on these free classes. So a little quick update about how the class works, some do's and don'ts. We have an assistant in chat. You'll see Gracie in there. And Gracie is there to help us just sort of manage the chat, answer questions, make sure people are nice. Please be nice. It's been a long time since we had to boot anybody out of these classes. We generally get really, really cool people to these classes. One of the things to expect is that you're going to be challenged a little bit. It is a free coding class, and we've tried to make it as accessible and easy to understand as possible. But part of learning any new discipline or subject is you're going to stretch a little bit, and you're going to face a few challenges. So just be ready for that. We'll get you through it. And one really big caution on that is then when we get to the point tonight where we're writing down actual code, please be sure to look at exactly what I type and write the code exactly the way I do it. I'll try to go slow, right? I generally do okay with that. But the reason for that is that when you're writing a computer program, even as something as simple as something capitalized that shouldn't be capitalized, or a little teeny typo, or a missing semicolon can break your code, make it so your program doesn't work right. So just write it exactly as I write it. You should be good to go. And finally, do whatever you need to do to make sure you're in a distraction-free setting. There's a lot to learn. I want you to get a lot out of it. And so if you got a bunch of noise and commotion around you, that'll be difficult. So see what you can do to control your situation, okay? Now, let's check out the chat, right? I want to be able to get to know some folks here and make sure you know how to use the chat. So go into chat if you would, and let me know where you're joining us from. I'm in Portland, Oregon right now. Drop into chat and let me know where you're joining us from. Excellent. Mohammed's joining us from Pakistan, so it's early morning for you. Yeah, totally good. Lisa, we got Lisa joining us from Cincinnati. Abu Bakar's Canada. Excellent. Stefan from California, Eastern Kentucky. Excellent. I'm glad you're here. Springfield, Illinois. I've been there. All right, I'm going to go grab a glass of water because I've been working my tail off today and I'm going to be talking a lot. So yeah, I normally live in Slidell, Louisiana, which is not far from New Orleans, but I'm up in Portland, Oregon, selling a house that we had up here. Thanks for your patience. Okay, come on, Derek. Now you're just making stuff up. You're not from Floyd's Knobs, Indiana. That's not a real town. I'm definitely going to look that up. Floyd's Knobs, Indiana. All right, good. Well, welcome, folks. Yeah, I'll try to watch the chat while we're teaching, but I'm going to miss some things because I've only got one monitor, so it's hard for me to watch the chat and teach the class at the same time. Oh, cool. Across the river from Louisville. But Gracie's going to watch the chat. And Gracie, if there's an urgent question, just break in, interrupt me, because I'm operating with one monitor until I get back home. All right, so here's our basic agenda for tonight. We're going to have a short introduction to the Tech Academy, who we are, what we're all about. And then we're going to write some code. I'm going to try, like I said, to answer questions during, but no matter what, we'll have a little bit of a Q&A when we're done writing code. And then we'll have some data about our coding boot camps. We help people break into the tech industry, and we're going to give you a little bit of data about how we do that. And we have a really cool free gift that I think you're really going to enjoy waiting for you at the end of the class. So sit tight and wait around for that. All right, so a little bit about who we are. We are a coding boot camp, and if you're not familiar, coding boot camps are brief, intensive technology certification programs to help prepare people for introductory roles. They've been around for about 12 years, and they generally last between 3 and 6 months, and they teach in-demand skills. At the Tech Academy, we've been offering cost-effective, highly rated, self-paced online coding boot camps for over 11 years. Like we were around right at the beginning of the industry. Okay. Um, and what we do is we focus on really in-demand skills, the stuff that gets people hired and is needed in entry-level tech workers, so that you have a shot at breaking into tech. Nationwide in America, the average price for coding boot camps is around $13,500 as of last year. Um, we're priced well under the national average. In fact, we have programs that start as low as $59.80. And the mission statement of our school is to graduate entry-level technology professionals that excel in the basics of their field, and thereafter go on to have successful careers in technology and whose actions raise industry standards. That's what we're all about, is you breaking into tech. All right, so we're gonna write some code here, but before we do, just a couple brief definitions. Some of these words you might be familiar with, some of them might be new to you. The first word is just a program, and this is just a set of written instructions that you can enter into a computer where you can make the computer perform specific tasks. Instead of using somebody else's program that lets you, do some work, you get to create the program that other people can use to do work or play games. You're going to write this program in what's called a programming language. It's not a spoken language, it's a written language. And it's like any language, it's an organized system of words, phrases, and symbols. But this language lets you communicate with the computer and tell the computer what to do. This is what you use to create computer programs. So there's the verb coding. This is the action of just putting those instructions into the computer. That's called coding, right? And then the instructions you're writing, you can call those code. So just some fundamental terms. Again, some of you may already be familiar with those. I do want to cover the actual programming language that we're using tonight. It's JavaScript. I'm sure most of you have probably heard of JavaScript, right? Very, very popular language. It's been around for about 30 years. And it's used to create both computer programs, and it's also used to add functionality to your websites, to make your websites really, really powerful and interactive and such. That's JavaScript. But there's another language that you kind of need to know about when you learn about JavaScript, and that's called HTML. It stands for Hypertext Markup Language, and it's a very specialized computer language which is used to make web pages. Specifically, it's what describes the appearance and the content of what's on the web page, whether there's big paragraphs or whether there's an image somewhere or whether you have a video player on the screen or whatever. HTML is how you control that. And finally, there's a third language you need to know about, which is called CSS. It stands for Cascading Style Sheets. This is another very specialized language. It's only about the web, and it's what's used to control the appearance of all that content on the page, like what color fonts are where, and do your images have outlines around them, and if you have a table of data, do we make it so every other row in the table is a darker color so you can read the table more easily. All these kinds of styling issues can be controlled with a very specialized language called CSS. Now, we're not going to have a full class on all three of these tonight. That's way beyond the scope of what we can do. We're going to teach the fundamentals of programming using JavaScript. But you kind of need to know about those other two in order to just move through the class, and they're just the basics of web development. These three languages are the primary things you need to learn if you want to do web development. All right. So with that said, let's go on to the actual most important part of the class. We're going to do a lot of coding tonight, and it's fun, and it's challenging, and it's very, very instructional. But this slide is actually the most important information we're going to share with you tonight. And that's because these 5 elements of a computer program that you're going to learn about are the only things you'll ever find in any computer program. There's only 5 things that any computer program is made up of. And when you understand them, it makes learning to code a lot easier. So let's break into the first one. It's called an entrance point. Any computer program, again, it's a series of instructions that make the computer do things. Any computer program has to have a first instruction. It's got to have a starting point. And this is valuable for 2 reasons. The first reason, excuse me. The first reason it's important is because when you start a program, the computer that you're using needs to do something really, really specialized the computer program needs to take some of the storage area in it, the memory that where it stores data, and reserve some of that memory storage area just for your program to use. And that way, no other program can use that memory storage area. If we didn't do that when your program started, then other programs might overwrite the information that you're storing in the computer memory, and now you have a problem. Your program is relying on incorrect data. So that's one thing that happens under the hood, so to speak, when you hit the first instruction in a program, is the computer reserves some memory storage area. But the other reason that would matter more to you as a programmer, the other reason that this first instruction is so important is that when you're trying to understand a computer program that you did not write, it's very helpful to know that there is, in fact, a first instruction. There's a place where the program starts. And if you can find that instruction, now understanding that program becomes much easier because you can follow along one instruction at a time from the very beginning and see what that program does. Otherwise, you're hunting around inside the big program trying to figure out what it does. It makes it a lot harder. So the first element of a computer program is the first instruction. The second element of any computer program is what we call variables. Variables are just data that changes. It's just data that changes. In other words, you start your computer program, it's keeping track of something, and that something can change while the computer program runs. This happens all the time. It's one of the things that makes computer programs really valuable. Well, that data that you're keeping track of that can change, you keep track of it with what's called a variable. And we're going to get into these when we do some coding in a minute. The third element of any computer program is what's called a control or branching setup or control or branching system. This is a way to set up decision points within a program. It's a way to tell your program, if this, then do it. If it's this way, do it one thing. If it's a different way, do another thing. In other words, you get the program to choose between two or more possible courses of action. This is super important in a program. It's one of the main reasons that people created programs in the first place, is to help automate a lot of decision-making processes. So we're gonna do this in code tonight, but this is one of those fundamental elements of any computer program, is the ability to control the branches that a program takes. And we're going to go into that. The fourth of these five elements, the fourth element of the computer program, is what's called subprograms. It's one of my favorite things about programming. You can think of it, like it says on the screen, as a program within a program. And what it really means is this. Often, when you're writing a very large program, you're going to find that there's a series of instructions that are identical that get used over and over again. There might be a set pattern of 5 instructions that you do in a row, and you do that pattern all throughout your program. Well, instead of having to type all that out over and over again each time you need it, it's really helpful to just bundle it all up into what's called a subprogram. And then when you need those 5 instructions to happen, you just ask for the subprogram to be performed. And again, you're going to build one of these tonight, so you're going to see what it looks like. But this development that happened in about the early 60s was a huge advance in computer programming. And the final element of any computer program is an exit point. You can probably figure that one out. There has to be a point where the program is done. And one of the most important reasons for this is that's what tells the computer that the program is running on, hey, this program's no longer running. And so if you've been reserving any of your memory storage area for this program, you can stop reserving it and let other programs use it. And if you don't do this, your computer slows down a lot. So these 5 elements are the only things you're ever going to find in any computer program. Now, 2 things. That doesn't mean computer programs are necessarily simple. They can actually be quite large and have a lot of things going on. It just means that when you look at all the things that are being written in the computer program, you're only going to find examples of these 5 things. And the second thing I want to point out is you don't necessarily put them in this exact order in a program. Obviously, the entrance point always comes first, and the exit point always comes last. But those other 3 things, you can make use of them in any order as needed, however many times you need them inside your program. The variables, control and branching, and subprograms. All right, with that said, I want to get going doing writing some code. So I need you to use a code editor. Now in chat right now, Gracie's going to drop this link, the link that you see right here. And that link is going to take you to an online editor, a place where you can write your code. I want you to open that up in your browser. Now, here's the next thing. This is really important. I want you to be able to watch what I'm typing, but also look at your code editor that you still opened up at the same time. So you're going to need to have my screen on the left and your code editor on the right. If you have any questions about setting that up, like here's your code on the right, you're going to see my code on the left. I need you to set that up. If you have two monitors, that's easy. But if you have one monitor, put your browser on the right and your zoom on the left. Sometimes to get zoom to collapse down and let you resize it and move around, you have to click on the word Zoom meeting and then restore. And then sometimes for the browser, you might need to click on the little symbol in the top right that looks like squares. And that way you can resize your browser. Either way, I need you to get it set up so that you have me on the left and your code editor on the right. And while you're doing that, I'm going to open my code editor. Oh, I think I opened it up already. Here we go. Now, let me explain what you're looking at. On the left here is a bunch of computer code. Some of it you might be familiar with, some of you might not. Don't worry about that, okay? On the right is an output window where you can make things appear, okay? There's other ways to make things appear as well. Now, here's the important thing. Most of what's on the left-hand side here is not a computer program. The only computer program here is this part, these 4 lines right here. That is JavaScript. The other parts are HTML. And remember, HTML lets you control the content on a web page. You can see, for example, that there's this content on the left here that says my heading, and you can see that content on the right. There's content here that's a paragraph. It says play around with the code and click on the run button, and you can see that on the right. And then you can kind of, if you look through this, see that somehow we're taking something and making it appear on the screen, but don't worry about that code. That's fine, okay? The important thing to realize is that when you look on the screen, the JavaScript is in between these two things that say script and /script. This is where we're going to write our code for tonight. This is where you're going to learn to program. Now, I gave you all that to let you know the kind of the landscape of what we're looking at. But first, I want to show you a little bit of the game that we're going to use as a guide for our work today. We're not going to write this whole game. So this is the classic Minesweeper that's on a lot of Windows machines. You have to try to find the mines. Let's see. Oh, I hit a mine. Okay, try again. Oh, I know there's a mine. Oh, look at that. There's a mine there. There's a mine there. That means I played a lot of Minesweeper as a kid and as an adult, let's be honest. So this is just Minesweeper. Okay. Oh, look at that. Ooh, yeah, boom. Oh, I hit a mine. So again, we're not going to write this entire program. There's a lot going on in this program that would be way beyond the scope of what we could teach. And frankly, you get so overwhelmed, you're not going to learn the most important parts of the class. And the most important parts of the class, in my opinion, having done this for a while, is if you were to take a look at those fundamental elements, those 5 fundamental elements of a computer program, how do you do those in JavaScript? How do they work? Because if you can learn those 5 things in one language, you can learn them in any computer programming language. So here's how we're going to do it. I'm going to do a Control Z and go back. So now I have what you have. Get a sip of water again. Now, this part you need to be very careful with. I want you to delete only what I have highlighted, what's in between the script and /script. Delete only that. All right. Now, we're going to write our first instruction here. What we're going to do is make it so that a little box pops up on the web page that has a message in it. There's an instruction in JavaScript that does that. Those little boxes that pop up are called alerts. You've seen them, I'm sure, 1,000 times on the web. So let's use the JavaScript instruction, which is ALERT, and then put an open parenthesis and a closed parentheses and a semicolon. And then I want you to run the program. And notice this little box popped up, the alert. Now it doesn't say anything in it, but you successfully got an alert box to pop up. Now, I know this may seem like a relatively straightforward instruction. Maybe it doesn't, but there's a lot of learning that can happen on this little teeny instruction right here. The first thing is this. When the computer reads this instruction, the first thing it does is it sees the word alert, and the computer tries to figure out, is that a built-in JavaScript instruction? And because it is, and because the computer has built into it a list of all of the JavaScript language, the computer goes, oh, I know what that instruction is. That instruction tells me to pop up a little text box that someone can close. Now, the important thing are these two parentheses. These are used to give information to an instruction that needs it in order to do its job. I'm going to repeat that again. Parentheses are used to give information to a computer instruction that needs that information in order to do its job. Here, the alert instruction actually needs some information to do its job properly. It's meant to display some sort of text on the screen. Run your code again, and you'll notice it didn't display any text on the screen. That's because we didn't give it any information. So right inside these parentheses here, we need to give it some information. And you're going to give it a type of information called text information or text data. Text just means a combination of letters and numbers. In most computer languages, JavaScript included, if you want to show the computer, tell the computer that the information you're giving it is text information, you put the information in between two double quotes, like that. So give yourself two double quotes. And then most importantly, make sure you put your cursor right back in between those double quotes. And now finally, we get to actually choose the text information we're going to display on the screen. Now, I'm going to have you build code that pops up a number of these alert boxes. So the first thing I want to do is just have the number 1, a colon, and then hello from the alert box. I like that. That's what we're going to have it print on the screen. So go to run your code once you're done typing that. And it says, hey, 1, hello from the alert box. It displayed exactly what we told it to. Now, if it didn't work for you, then make sure that you've got 2 double quotes. Make sure they're inside the parentheses. Make sure that the text that you want is inside the parentheses. Make sure you didn't forget your closing parentheses. And then one final thing to mention is, what is this semicolon thing here? This is what tells JavaScript, hey, I'm done giving you the instruction, now do it. After this would come another instruction. All right, take a sip of water. So we have our first instruction. It's pretty obvious what it is. We know it's the first instruction because it's the first thing that comes after this script thing, and we watched it work. Now let's set up some variables. In JavaScript, there's a few different ways to make these variables, but the most common way is to use a JavaScript instruction, which is called var. It stands for variable. So type var, and now we're going to give our variable a name. In this case, we're going to say, is there a mine? A variable is going to be called mine. and then put an equal sign, and then type true and a semicolon. Let me explain what we're doing here. We've made a variable called mine. Now, let me talk a bit more detail about what it means. I mean, when we say we made a variable, the computer that we're using for this program has a bunch of memory storage areas, places where it can store data for use by the program. We call them memory locations. And what we've done here when we say variable mine is we've found one of those locations in computer memory, and we've given, this part is important, we've given the location a name. We haven't yet said what's stored in that location, what information is stored there. We just said this location is called mine, M-I-N-E. Think of it as memory is like a huge collection of millions of buckets. And you can put stuff in the buckets. That's the information you're storing. But you also need to be able to find a specific exact bucket. So you put a unique name on the outside of the bucket. That's what mine is. That's the unique name on the outside of the bucket. That's the name of our variable. Now, what we've done here with equals true is we've stored information inside that bucket. And the information we've stored is a special type of data, which is true-false data. It can only store the value true or the value false. That's all. You can't store the information, the value Wednesday. We're just storing true or false inside that bucket. So the terminology is that this part that I've highlighted is called declaring a variable, and this part is called assigning a value to the variable. So let's use this right here. I want to do another alert, A-L-E-R-T. And here I'm going to do my open and close parentheses and a semicolon. Go back, do my double quotes, go back. And then we're going to say, did you hit a mine, question mark. And this part is important. We want to use this value here of true. We're going to use the value of the mine. We're using this variable mine to store whether or not there was a mine where they clicked. If they clicked a mine, great. If not, we'll do something else, which we're going to get into. But right now, we just want to store whether or not they hit a mine. So let's go ahead and run this right. Oh, go back here to before the did you hit and do 2:, like that. Because this is the second alert. I want you to be able to keep track easily of which alert pops up. So it's going to run your program. And notice that once you close it, the next alert box pops up. Which we can close it, and we're done running our program. But here's the thing. I want to be able to have right here after did you hit a mine, I want to be able to say yes or no, or true or false. So go right here. Notice where my cursor is. It's right after the double quote and before the parentheses. Hit a space and then a plus, and let's type out the name of our variable, M-I-N-E. Now, this is probably going to throw an error, but it's going to be fun to explain what the error is. So go ahead and run it. There's the first alert. Oh, it worked. Awesome. JavaScript's great. So let's look at that again. You can run it as many times as you want. There's hello from the alert box. And then did you hit a mine? True. Hey, we hit a mine. That's not good. All right. Now, did everybody notice that the word true was right after the question mark? Let's run it again. Hello from the alert box, which is this instruction. And then we've got, did you hit a mine? And there's no space after the question mark. I don't like that formatting. Let's go ahead and fix that by going right here after the question mark and hitting a space. Now run the code. There's the first alert box. There's the second, and notice we have a nice space because we put one right here. All right. Now, we've got a variable here called mine. And we're pretending that someone actually hit a mine. So let's hit enter again, and let's change the value of the variable. Remember, variables, and mine is a variable, are there to store information that can change as we go through the program, as your program runs. So let's say that mine equals false. They did not hit a mine. Don't run the code yet. I'm going to go to chat, and I want you to take a guess, drop into chat, and let me know when we run this, what is the final alert going to say that pops up on the screen? Drop it into chat. Yep, that's correct. Abu Bakar, that's great. Tanja, that's not correct, and I'll show you why. Stefan, that might be true. We'll find out. All right, so let's go ahead and run the code. Here's the first alert, hello from the alert box. Here's the second alert. Did you hit a mine? True. And then let's close again, and that's it. So you might wonder, if we change the variable mine to have a value of false, why did it say, did you hit a mine, and then say true? Here's the thing. When you start a program running, it has no memory of anything that's ever happened before. It starts from the beginning. And from the beginning, we create a variable called mine, and we set it to true. Immediately after that, we made an alert pop up that uses that value of the variable mine. And at that exact moment in time, the value of the variable is still true. The computer does not know that right after we're done with popping this alert up, we're going to change the value of mine. The computer has no idea, because the computer can only do one thing at a time. And it's going to do this instruction before it goes on and then does this instruction. Hope that helps. But now let's make use of that. Let's do another alert. Here's your alert with parentheses and a semicolon. Go back and do your double quotes, then go back, and this is going to be alert number 3. So do a 3 colon. Did you hit mine? Question mark, base, and it's the same thing, plus mine. It's very similar, isn't it? Now here, yeah, we got our hello from the alert box. That's number 1. Did you hit a mine? True. And did you hit a mine? False. Now that's kind of cool. Why is it cool? We were able to change the value of a piece of data we were keeping track of and use that newly changed value in our program. Kind of a boring example. Did you hit a mine? But actually, isn't that what this game is all about? About whether you hit a mine or not. So take a sip of water. Then we're going to get on to a kind of a fun thing. So the truth is that we need to be able to, every single time someone clicks on a button, clicks on a square on the minefield, we have one of 2 possible things that could happen. If they click on it, either it's not a mine and we clear the square, or it is a mine and they lose the game. That is a perfect situation where the next element of a computer program can be used. Remember the 5 elements of a computer program: an entrance point, variables, control and branching, subprograms, and an exit point. We're going to talk about control and branching now. In fact, why don't we learn a new thing, which is a comment. I think we can go // Yeah, this is a comment. Now let's look at control and branching. This is a comment. Comments are only there for human beings to read to help add some understanding to your program. The computer won't do anything. To test that, let's run our code. Hello from the alert box. Number 2, number 3. And there's no error. This didn't error. The computer ignores this. It's just a comment for us. Okay. So here's the thing about control and branching. We're going to give the computer information in order to, based on its decision of 2 or available decisions to make, right? Think of it as coming to a fork in the road, except that there might be more than 2 different paths you can take. There might be 3 or 100, doesn't matter. It's still, you need to control which one does the computer take. That's control. Branching is setting up these 2 or more paths that can be taken. That's what branching is. So we're going to learn about both. First of all, the control instruction that's used most often in JavaScript is called if. And let's do an open and close parentheses. And then let's do a space, a curly bracket. You can find it above and to the left of your return key. Hit enter a couple of times and do the closing curly bracket right near the other curly bracket. And then I want you to hit enter and another programming language, another JavaScript instruction called else, a space, and a closing curly bracket. Now, once you're done with that, I'm going to give everybody up. We're going to fill in more instructions here, but this pattern, it's the pattern and understanding the pattern that's super important. Grabbing some more water. Again, thanks for your patience. So let me explain this pattern they're looking at. Remember, we said control and branching is all about telling the computer to take one of 2 or more available courses of action. That's what control and branching is all about. The control instructions are the if and the else. The branches, or the possible courses of action that can be taken, are what's inside the curly brackets. These are called branches, or they're also called path of execution. It reads almost like English, doesn't it? If blank, do this. Else, do this. That's what this instruction system is all about. It's called control and branching. So the first thing we need to figure out is, what condition are we asking the computer to evaluate? What data are we giving it that it can use to make a decision? And what we want to do right now is we want to determine whether or not the square the person clicked on has a mine. Or really, more importantly, we're going to lay out what to do if it has a mine, and what to do if it doesn't have a mine. So right in here, we need to give the information about whether or not the square that we've clicked on actually has a mine in it. So we'll say this. We're going to have we have a variable here called mine, and we've been using it to store whether or not we clicked on a mine. So we're going to say if mine, and this part's important, space equals equals, type two of them, and then true. So let me explain what we're doing here. This little symbol right here of two equal signs right out next to each other, it's a very special symbol that tells the computer to compare two pieces of information and see whether they're equal to each other. In this case, we have the value true, which is a built-in value in JavaScript. It's just the concept of something being true. Over here, we have a variable that we created called mine. And mine could be either true or false. So we're basically saying if mine is true, then do what's in here. Else, do what's in here. So let's lay out what we're going to do. Now, inside this set of curly brackets is where we're going to put a branch, we call it a path, of what to do if the value of the variable called mine is actually true. And what we're going to do is we're going to pop up an alert that says, you lose. Now, to make it a little more readable, hit space 3 times, 1, 2, 3. It just makes your code a little more readable. You don't need to. It works fine if you don't do it. But I like it because it makes your code more readable. And then type alert, like we've used before. And then we will do your open and close parentheses and a semicolon. And we'll go back and just like we did before, we'll do a couple double quotes. We'll go inside there and say, you hit a bomb. Oh, I think we're going to caps. Bomb. There we go. And now let's set what to do if mine is not true. Again, do your 3 spaces here, do an alert. So open and close parentheses and a semicolon, your double quotes. And now we put in here, no bomb. Good job. So here's my question. Don't run the code. What message is going to be in the final alert that comes on the screen? Put that in the chat. What message will be in the final alert? Chip, that's not correct, but I'll show you why. Oh, no, that's right. That's right. That's right. That's right. That's right. Yep. Good. So let's go ahead and run the code. There's our alert 1, hello from the alert box. Alert 2, did you hit a mine? True. Alert 3, did you hit a mine? Well, we just changed it to false right here. The value of the variable mine is now false. And now we hit our control and branching. We hit an instruction that said if mine equals true, but mine was equal to false at the time. Why? We set it to this back up here. So we did not do the branch inside these curly brackets here. This is alert, you hit a bomb. Instead, we did this branch. No bomb, good job. Now, what would happen? Because again, mine is false. Let's say they click on an actual bomb. We would make mine equal to true. Now, before we start typing it out, I don't know about you, but I don't particularly want to type all of this code again. I know that that's the behavior I want. I know that I like the alert that pops up either way, but I don't want to have to type all that out again. Like every single time someone clicks on one of the squares, I have to put this instruction in my program. No. First of all, it takes a lot of extra time. And second of all, it's very error prone. It's really easy to make a mistake or I have to do a bunch of cut and paste. And worse, if I wanted to change the way my program behaved when someone clicked on something, I'd have to go through and change every single time I had these exact instructions. Well, it sounds like a perfect situation for that fourth element of a computer program called a subprogram. We want to set up this exact logic where we check whether or not a variable is true. And if it is, we tell them they hit a bomb. If it isn't, we tell them no bomb, good job. We want to set up this exact set of instructions to be called on anytime we want it. We wrap it all up in a little box called a subprogram. In JavaScript, that's called a function. And so go down to the very bottom here, and I'm going to do a comment. Now we turn those 5 lines into a subprogram. We call them a function in JavaScript. And by the 5 lines, actually, it might be 6. 1, 2, 3, 4, 5, 6. Yeah, it's 6 lines of code. So now we turn those 6 lines into a subprogram. Here's how you do that. We're going to, and this part's really, really important. It's just really important. I know I've covered a lot of stuff tonight. I'd like you to pay attention to this part really closely. When you're making this thing called a subprogram or a function, when you write the instructions to make the function, you are not asking the computer to do anything yet. You're just saying, hey, here's a set of instructions that later on in the program I might use. Don't do them yet, Mr. Computer. A function is just a description of some potential instructions that could be used if you even want to. That's really important. But let's make one. You use an instruction in JavaScript called function. There it is. Type function and do a space. And we need a name for our function. We're going to call this check underscore. It's right. It's the shift of the minus key. Check bomb. That's a nice function. I'll like that. Check bomb. I like that. And now do an open close parentheses, a space, a curly bracket, enter twice, and a closing curly bracket. Seem familiar? Here's what we're doing. We're saying inside here is going to be the set of instructions that we want to have happen when we ask for the check bomb function to be performed. We haven't typed them yet. It's blank right now. There's nothing in there, but that's what's going to go in there. We need one thing, though, before we start writing those instructions. We need our function to be given some information. Remember all the way back at the beginning, I said that we have this instruction called alert, but it needs information in order to do its job. And we're going to put that information inside of parentheses. That's how we give the information to the instruction. Our instruction or our function check bomb is no different. We might need to give it some information, and we give it information inside parentheses. So what you put right here is, and this is really critical, if information comes in to the function when it gets asked to do its job, what should the function call that information? I'll say that again. If information comes into the function or is given to the function when someone asks the function to do its job, what should the function call that information? I think the information that it receives should be called a click, because someone clicked on a button and we want to give it whether or not there's a bomb on that button. So I'm going to call it click. That's the information that's going to come in, and it's going to be either true or false. Did the click uncover a bomb or did it not uncover a bomb? Regardless, I want to say it one more time. What goes inside these parentheses when you're making a function is the name that the function will use for any information it's been given when the function is asked to do its job. I'll show you how to use it in a minute, but that's what goes inside the parentheses. It's called an argument. That's what goes inside. It's called an argument. I know it's kind of a weird name, but the argument is what the function is going to call the information it receives. Okay, now let's figure out what we're going to put inside here. Well, we kind of know the logic. We wanted these 6 lines right here. We want those to be in a subprogram. So let's create that same sort of logic, but we're using this variable now. We're using the variable that the function has. So go inside here, hit your space 1, 2, 3, and do if parentheses click space equals true space end parentheses, and then you got your curly brackets. Hit enter twice, and end curly bracket. Then you got your else. Oh, well, you can enter first. Else, a space, your curly bracket. It's just the same pattern you saw before. It's the same pattern here. Oh, I don't know if we're allowed to use the word click. Click might be reserved for JavaScript. Let's change this to square. Like is the square a bomb or not? So change that to square. We changed the name of our oh, I guess it's just the color coding in this editor. That's fine. Let's leave it at square. That's fine. That just kind of shows you can name the variables anything you want. But now we know, now we've got our logic we built. We've got if this is true, then do what's inside these brackets. Else, do what's inside these brackets. So let's go inside the first one, 1, 2, 3, and we'll do an alert that says you hit a bomb, game over. Like that. Otherwise, let's go inside the other one here in the else, 1, 2, 3. We'll do an alert that says no bomb cleared out empty spaces or squares for you. Because that's what's going to happen in the game. That's what happened when I was playing the Minesweeper, and that's what happens when you play it in the real one on a Windows machine. If this isn't a bomb, it clears out any empty squares around it. So don't run the code and pay close attention. You have to read through this program like a computer. Tell me, what is the final alert going to say when it pops up on the screen? Put that in chat. What is that final alert going to say? Lisa? They're called parameters when you call the function. They're called arguments when you create the function. which is a nerdy distinction, but I got it messed up so many times. I try to nail it down. Okay, so put into chat, what do you think the final alert is going to say when we run this? Chip, you're a genius. Abu Bakar is a genius too. Nope. Sorry, Stefan. It's not going to say that. So let's run it and then we'll go through the code. So run it. So here's number one. Hello from the alert box. We've all seen that a million times now. Close it. Here's number two. Did you hit a mine? True. Why? Because variable mine is true. And here's number three. Did you hit a mine? False. This came up that said, well, we changed the value of mine to false, so it says false. This says no bomb, good job. Why? Well, because now we said if the value of mine, which is false, if that's equal true, it's not false. Sorry, false does not equal true. So we go down here and we do no bomb, good job. And now watch what happens. We close this. That's it. End of program. We did not get this. And the reason for it is this. Remember what I said, when we're creating a function, we aren't asking for the function to be performed. These instructions will not be executed unless we deliberately, explicitly ask them to happen after we made the function. The function is just a name you can use if you want these instructions to happen. If you want these instructions to happen, you say, hey, check bomb. Here is the results of someone clicking on a square. Do your job. Let's do that right now. Go to the very end, right here. Hit enter a couple times. And give myself a little more room here so that y'all can read. So now we're going to do what's called call the function. This means give it the info it needs. Let's assume someone clicked a square with no bomb. So someone clicked a square with no bomb. No bomb. We've decided that we need to figure out what to say on the screen now. So you call the function check underscore bomb. That's the exact name we gave it right here, right? And then you put in parentheses whether or not the square had a bomb. False. It did not have a bomb. That's all. Run this now. Here's our number one. Here's our number two. Here's our number three. We've seen that a lot. Here's the no bomb, good job. Now, look at that. No bomb, clear out empty squares for you. And that happened because we called the check bomb function and we passed in false because there was not a bomb in the square that we clicked. And let's do it again. Let's say they click on another one. Check underscore bomb. And this one also did not have a bomb. Run it again. Here's all the alerts. Dun, 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 the three. No bomb, good job. And here we go. That's the first time we called it. No bomb, cleared out empty squares for you. Click it again. No bomb, cleared out empty squares for you. So we are, every single time someone clicks on it, we get to find out or figure out what to do simply by calling the check bomb function and passing in whether or not there was a bomb. So let's see what happens if they finally click on a bomb. We call check bomb, and we pass in true. It's all over, sorry. So let's run it again. Here's our number 1. Here's our number 2. Here's our number 3. Here's the one from the if. See, it says no bomb, good job, we did that one. And then we called the function the first time. We called it right down here. We called check bomb and passed in false. So it said no bomb, clear down 3 squares for you. Click close. We called check bomb again and passed in false. And so again, because we passed in false, we got alert. No bomb, clear down 2 squares for you. Click it again. And now we call check bomb again, but we passed in true because the person clicked on a square that had a bomb. And so now our function gets called, it receives true. And because it's true, we print you hit a bomb, game over. Now, I don't know about you, but I find this a lot easier to write than all of this. And let's say I wanted to change the message. You hit a bomb, game over. Sorry, dude. I only have to change it one place, and that gets used throughout my entire game. It's much easier to maintain. So that is what we call a subprogram, or in JavaScript, we call them functions. In several different languages, they have different terms: subfunction, subprogram, subroutine, method. There's lots of different words for the same concept. You are creating a repeatable chunk of instructions that can be called upon later on in your program whenever you need them, which is really, really valuable. All right, now I want to give you an opportunity to look at the game, the actual Minesweeper game. So Gracie, can you drop the link to this code into chat? When you get it, just copy all of it, like Control A, Control C. Go back to your code editor, and then Control A, delete everything you have, and paste in your code. And then you can run it. And I want you to play a game. And then we're going to look a little bit. Ooh, look at that. Right click to mark a flag. Jeet. Man, I love this game. Oh no! I hit a mine. Okay. All right, so let's talk a little bit about this program here, okay? So go to the top here. First of all, this stuff is all HTML. We're not going to pay attention to it. This stuff, where it starts with style, this is all CSS. This is styling stuff, right? This is what makes it so that the grid looks the way it works, that the background color of each cell is gray. Like if a cell is a mine, this is the background color. Okay. And if you flag a cell, this is what makes the content be a flag, like this. Okay. But we don't care about that. That's CSS. What we learned is JavaScript. So scroll down here to where it says script. Everything between here, where it says script, and all the way down here, where it says /script, this is the code that makes this game work. Right here. This is our program. Now, you'll see a couple of things you recognize and some you don't. There's a special kind of variable in JavaScript called a constant. So we're making a constant. Here's another constant called grid size. Number of mines, that seems pretty obvious. We have a grid array where we're going to figure out where the flags are or where the bombs are. So we're going to create the grid array. With a little bit of Googling, you could probably figure out what's going on here. We have a function called initialize grid, and we have some assigning values to variables. Here's assigning values to variables. We've got some data types of false. You've seen some of this stuff before. And the point is that if you were to look up, say, let, you'd find out it's just another way of making a variable in JavaScript. But now you have that framework of what are the 5 basic elements of any program: entrance point, variables, control and branching, subprograms, and exit point. And everything you see here, this instruction let, this instruction constant, the for, these are all just simply examples of one of those 5 things. Let is another way to make variables. While is a control instruction. For is a control instruction. These, of course, functions are subprograms. So you can start to understand the structure of what these programs are, even if you don't 100% know the programming language yet, just by knowing these 5 fundamental elements. So this code is yours to keep, by the way. You can play the game. It's a fun little game. Again, I happen to love Minesweeper. All right, now I did a little bit of looking around for some Q&A, okay? But I want to have a chance to see if there's anything else I'm missing before we go on. Oh, Stefan, yeah, you were right. You were right. And Lisa, yeah, good job. Yep, Abu Bakar, you were exactly right. Okay, good. Excellent. Lisa says, for bonus points, we can program our own win condition. Don't cheat. Oh, it was really weird. All the bombs were just in a row along the right-hand side. I wonder why that was. Oh, that's great. Yes, Lisa, that is bonus points. Or you can change the messages that happen when you win. Just mess around with that program. It's fun, you know? Oh, I see what you mean. Yeah, Lisa. Yeah, you're right. You can have whatever message that happens when you win. Yeah, Abu Bakar says, can we put comments in other parts of the code outside of script to help us make sense of it? Absolutely. Absolutely. Like if we go here and you're like, okay, let's say you finally figured out what this does, calculate neighbor mines. You could go right after this and go, here is how this function works. And you can put your notes. Keep notes to yourself in there. It's a smart thing to do. It doesn't hurt anything. The program's the computer's not going to run that. It's just for you or for someone to come along later. In fact, it was a good question, Abukar, because things that you learn when you're becoming a programmer is the value of leaving good comments in your code, not just for other people who have to come in later and try to understand your program, but quite frankly, for yourself. If you return to a computer program that you wrote even a few months before, it can sometimes be really hard to figure out what you were doing and how the code works because it made sense to you at the time when you were writing it, and that's great. But you had gone through a bunch of reasoning to get to that point, and you got it working correctly, and you were super happy that you got it working. But then 3 months later, you come back and you're like, now what is this and how does this work? And so sometimes you leave comments for yourself, if not for anybody else. That was a great question, Abubakar. Love that. All right. Let's move on. And again, please sit tight. We got a free gift coming your way. Okay, so a bit about who and what we are and what our boot camps are. And I just want to stress something. I can give you this whole big kind of sales pitch and this and that and the other. I'll just say this. Anybody can do our boot camps, whether you have technology experience or coding experience or not. You don't need to be a nerd. They're totally self-paced, which means you can move through the program at your pace. If you learn some subject really fast, great. No one's going to hold you back. If another part of it is a little more tough for you and takes a little more time, that's fine. It's self-paced. You can take the time you need to really understand it before you move on. And you're not going to be left behind because the whole class has gone ahead of you. We don't run our boot camps that way. They're also arranged on a gradient, which means you learn the most fundamental, super important, basic elements first. So you have a really solid foundation, and then you start to layer complexity on top of it so you don't get overwhelmed. That's how our boot camps work. They're very well priced. They're below the national average. They're highly rated, right? Which we'll get into in a second here. Oh, by the way, we have more boot camps than any other boot camp company on earth. We've got 12 different boot camps, which I can't pull the slide up for because I apparently don't know how to use PowerPoint. But yeah, we've got 12 different boot camps. You can see here, we've got like cybersecurity, JavaScript, Python, data science, game development, AI. Our AI developer boot camp rocks. And I'm telling you, been in this industry for a long time. That's a smart place to go, is AI. All right. We regularly receive, top acknowledgments from the best, awards that come out in our industry. In fact, last month, and I think, yeah, it's January, Newsweek released the top 31 boot camps in the world, and we were on that list. We're super proud of that. Our average review rating across all the boot camp review sites is 4.8 out of 5 stars, and those reviews come from students and graduates, which makes us very happy because that's the person whose opinion you should listen to the most, more than mine even. So, quick thing to point out, why you might even consider working in tech. Look, I know you took a Friday night. Well, you could be doing anything. And you spent some time learning some of the fundamentals of learning how to code. Maybe there's some interest in working in technology. I can tell you that working in tech has really good work-life balance. You don't often find jobs in technology that have you working 70, 80 hours a week and incredibly rigorous schedules. You have good work-life balance and remote work is available. It's also really creative, satisfying work that you can take pride in. And it pays well. It pays well above the national averages for a lot of different industries. And if you work really hard, you get regular increases. You can make a lot of money in tech. Pardon me. Not that it's all about money, but it helps. That said, there are some barriers to entry to doing a boot camp. We fully acknowledge that. Whether it's our boot camp or someone else's, there's some barriers. And the first one is money. It can take thousands of dollars in tuition to get through boot camp. Now, we've attempted to do whatever we can to make that a lot more confrontable and handleable, including very large upfront discounts if you can pay upfront for boot camp, and a variety of monthly payment plans for people with in any economic situation to make it, workable for them. But I'll just say this, I truly consider getting to a Tech Academy boot camp to be an investment in yourself. You're giving yourself a set of skills that's going to serve you in good stead for the rest of your life, and skills that are highly in demand. One other barrier to getting through a boot camp is time. There's just a lot to learn, honestly. We've done a really good job of packaging it up and making it concise and teaching you the things you need to know, but there's still a lot to learn. Some boot camps try to solve this by making training go in cohorts. Everybody starts on the same day and they move through the material at the same pace. I think you can tell how we feel about that because our boot camps are self-paced. I can't stand that method of learning myself, and we don't do it. And finally, you're going to need to have at least some technical interest and technical ability. But I'll tell you this, if you've ever even for a moment felt like maybe you weren't smart enough to be in tech, or it's just too complex of a subject, I'm here to tell you that the fault lies with the material you're studying, not with you. And it happens fairly often because a big mistake a lot of technology educators make is they assume too much prior existing knowledge on the part of the student. They forget what it was like to be new to the subject. And so they give you material to study that assumes you already know a bunch of stuff. And it's really frustrating. With our materials, you don't have that. If you can read, write, and do basic math, you can get through our programs. So the question I have for you is it time for a change? Like, Have you hit an income ceiling at your work? Are you in a dead-end job? Is it like you look ahead 10 years from now, there's no way it can make you the money you need to? Or maybe you want more time with your loved ones, or you want the possibility even of remote work. Like maybe you work in a job where you can't even do remote work, right? So for this and a whole other variety of reasons, is it true for you that it's time for a career change? If it is, I want to put forth the idea that the Tech Academy is a solution. We genuinely are career change experts. At this point, we have over 11 years of expertise in helping people transition from a incredible variety of careers into technology. And that's what that orange bridge represents in our logo, is we're trying to build the route into tech for everyone. And it works. We have thousands of graduates. On average, they earn about $30 an hour in their first role. And they've been hired at an incredible variety of companies, anywhere from small companies, medium-sized businesses, to giant places like Apple and Disney and Uber and Epic Games and Facebook, right? People get hired all over the place from our company, or from our school. Now, if this is at all of interest to you, it's the 28th. It's the last day of the month because it's February. All right, I'm going to make a decision here. We were going to end this at the end of this month, but we're going to do it for March. If you sign up in March, you'll get a full 50% off your tuition if you can pay up front. So if a boot camp is $10,000, if you pay up front, it's only $5,000 as an example. Okay, it's the biggest discount we've ever offered. We don't go below 50% discount. If you, by the way, if you pay up front like that and you need a laptop, we'll ship you a refurbished laptop that you can use to do your boot camp. That not only is available if you're in America. I'm sorry, we can't ship them around the world. Also, if you sign up in March, there's no sales tax. We'll pay the sales tax for you no matter where you live. Another specific gift we'll give you if you enroll in March is a set of our books and dictionary. There's 3 coding books that we've written that are super helpful, and a computer basics dictionary that has thousands of simple, clear definitions for all these wild technology terms that you learn. Also, if you sign up in March, you'll get your own physical copy of our career planning guide. This is an amazing book that takes all the expertise that Jack, my co-founder, and I have compiled in our combined 55 years in technology into how do you plan the first 3 years of your technology career? What do you pay attention to in the first 6 months? And what do you not need to pay attention to? How do you plan your 18-month mark in your career? What do you try to get done by the time you're in 3 years? Step by step, it lays out the entire solid foundation for a career for you. Also, if you enroll in March, you'll get 3 months of free access to what's called the Tech Academy Accelerator. I love this service. It's a subscription service that, first of all, gives you access to over 100 educational videos and mini courses, but it also gives you access to our weekly workshops in the accelerator. And these are awesome. They are deep dive accelerators to your career where I lead them. They're open voice, open chat, cameras on. We're all there as a community, and we dig in deep and learn really, really cool things. Every week, I get to teach something in a very deep way instead of the surface level that I have to do for some of these free classes. And so we build things, we break things, we have a lot of fun. So you'll get 3 months of free access to that. And by the way, we keep the recordings of all of those, and they're only available to Tech Academy Accelerator subscribers. So we've got almost a year of all these workshops we've done in an incredible variety of areas that you can start going through as soon as you join the accelerator, which is really cool. And finally, if you enroll in March, we will give you unlimited job placement assistance. This means when you've gone through your course of instruction and you've gone through our job placement course, you'll transition to working with our job placement specialists, and they will work with you for as long as it takes for you to get your first job, period. There used to be a time limit on that, but we piloted this a few times, and we're willing to do it. I just made the executive decision. I'll have to tell Jack, and we're doing it for March. If you sign up in March, you'll get unlimited job placement assistance. So if this is of interest to you at all, grab some information. Gracie's going to drop this link into chat. And when you click on there and fill out the simple form, you're going to get access to a selection, or sorry, a series of really valuable educational videos and articles about the school and how it works. Any question you have about what do we teach exactly? What order do we teach the subjects in? Why is it in that order? How do I interact with instructors? How do I do my practical work? Who's going to evaluate the work I do? These and any other question you might have are fully answered when you go through the steps after you fill out that form. So take a moment, fill out that form, and look, obviously I'm biased, but most of my adult life has been spent helping people break into technology. We're really, really, really good at it. All right. I also want to tell you about our referral program. Since students and graduates really like us, they've referred a lot of people over the years. And so we put in place a referral commission program where you can get a 5% commission check if your referral ends up signing up for the school. And that's not just for students and graduates. That can be for you too. So in a moment here, you're going to get an email address to use when you get our free gift, and you can send in referrals on that, and you're eligible for a 5% tuition, a 5% check of their tuition if they sign up. We've published 6 books and a dictionary, including those 3 coding books that I talked about. A coding book for kids and young adults, a project management handbook, a technology basics dictionary, which is awesome. I talked about that before. And probably the thing that Jack and I are most proud of, a book called You Are Not Stupid, Computers and Technology Simplified. It removes all of the mystery anyone could ever have about virtually any type of technology or computers. It's a phenomenal book. Which brings us to our free gift to you. We will send you your own copy of Learn Coding Basics in Hours with JavaScript. This is the 2nd edition of this book. It's been fully revised. It is a phenomenal learning to code book. You know those 5 fundamental elements of any computer program? I was only able to go into a tiny bit of detail in that in tonight's class. They are fully explained in detail, as an example, in this book. And there's page after page of coding exercise and explanation and practical drills. It's a phenomenal book. If you want your own copy, just send us an email at books@learncodinganywhere.com. Gracie's dropped into the chat, and give us your mailing address. Unfortunately, we can only send a physical copy if you live in America. I apologize for that. If you're overseas and you want a copy, I think it's $2 up for Kindle. Like, they're super inexpensive on Kindle, and you can find it on Amazon just by looking up Learn Coding Basics in Hours with JavaScript. You put Erik Gross or Jack Stanley. You can see our names down there, and you can find that on Amazon. But if you want your own physical copy, give us your address. We'll send you a copy. Give people a second to grab that email address. I also want to tell you about our link tree. This is a service some of you may be using this already. It's a place where you can put all of the links related to you or your business. At our link tree, you can find virtually any link you care about for the Tech Academy, including a link to our free YouTube educational video channel, links to our books, the dictionary, upcoming free classes, all of our social media. There's a lot of links on there. So check that link out. Check out Linktree. It's super valuable for all things related to the Tech Academy. So finally, I just want to say thank you. Like, again, you all took a Friday night, or for some of you, I see Abu Bakar on there. Some of you, it's early Saturday morning, right? And you didn't need to do this. And you came and took some time to explore something that's of personal interest to you. And I really appreciate that. I admire it. And if anything about the subject, the way we teach, the school interests you at all, then you owe it to yourself to check it out and see if it might be a fit for you. Other than that, thank you so much. I'm going to end off and depart the house that I've owned for 6 years because it just sold. And as of an hour and a half ago, it's no longer mine, but they let me stick around to teach this class. And yeah, on to a whole different place. So thank you all so much for the evening. Appreciate it. And I'll see you in future free classes.